So here we have a question typical of the sort of thing that might be on a higher level GDC paper. The problem being that the question has been given and involves two curves. One, the subject is y, and the other one, the subject is x. So let's see what we'd have to do. If we start by plotting this first function on our calculator, and we can go straight to this if it's a GDC paper, we plot x cubed. We're then going to plot this function. Well, we've got to have that in the same format. It's going to have to be y equals x plus 3, and that's going to have to be square rooted. So we plot the same function here, plus 3, and then we ask it to draw it, f6, and we see our first problem. Clearly, the calculator is plotting the square root of x plus 3, but it's only returning one value, the positive value. So we have to go back to the drawing board and back to the calculator. We have to help it along a little bit. We'll need it to plot the negative value as well. So in that case, we'll need both the positive and the negative square root. So we go back here and we place the negative square root of x plus 3, and we ask you to draw that. Now, we now have some chance of getting the answer, but we've got to be able to write things down that are going to convince the examiner that we know what we're trying to do. So we need to find the area that's enclosed by those two curves. So it's pretty obvious what that area is. You need to sketch that to show the examiner. Well, obviously, in this case, I'm going to capture that screen, which will make my sketch a little bit better. And you need to sketch this and actually show the examiner which region that you're trying to find. Now, there's other information you need to have on that as well. So, if we return back to the previous screen, we'll need to find out some points on our curve. So let's return back to here and let's try and find where those graphs intersect. And we've got to start planning a way in which we're going to explain to the examiner how we're going to find this area. So the intersect is going to be with that line. We'll choose that line. And with the top part of the square root, we'll choose that as well. And there we have the intercept at this point. So make sure that you explain that to the examiner. So make sure that you plot those intercepts so that you're actually giving information showing that you've taken some control of the situation, and don't round off at this stage. You've got the intercepts off your calculator and put them down. So we also need this one. So we'll come back out of that. We'll go back for GSolve again, intersection. It will be that line again, but this time the line on the bottom, and so that's the second intercept we have. So that will be at minus 1.111766, a little bit farther, and minus 1.3741. These aren't going to be final answers. They're just showing the examiner we've got some control over what's going on. The information I've put down there, the sketch diagram, the coordinates, is going to get me marks. I now need to explain how we're going to find the area. And again, you may do it by a sketch. The area I'm going to go for will be the integral of the square root of x plus 3, and that will have to be between the point where it reaches the x-axis, which is clearly at minus 3, and the point where we've got here. Now at that intercept we're at minus 1.111766. If we integrate that function between those two values, we're going to get the area on the top. So when we've done that, we need to double it so that we get the area on the bottom as well. Now the next part of the area is going to have to be added on, and it's going to be the integral that gets you this area. So it's the integral of the top line, which is just the red line as shown on that test diagram there. So it is just the square root of x plus 3. But we're going to subtract from that the function underneath, the line that comes down through the origin, and that of course is the line x cubed, because we want the area between those two curves, and it's between the intercepts at minus 1.111766 and the x-intercept up there, which is 1.2739 with respect to dx. Now, the first section has actually shown the examiner you have some idea of what you're plotting. You've now given the answer. This is how you're going to find the area. And the rest of the work you've got to do is of course going to be on the calculator. So let's return back to the calculator, go up to the normal run mode, we'll need the integral. I'll just back out of that. I'm going to need 2 times that. I need to put in my function here, shift square root x plus 3, and the integral is between these 2 points. Absolutely no chance with this kind of accuracy of failing to get the correct answer. Okay, the next thing we'll need to add to that another integral, and this is going to be between the next 2 intercept points, but the function will be again the square root of x plus 3. Move away from that square root sign because we want this function separate, minus x to the power of 3, and the intercept points and between minus 1.111766 and 1.2739. Well worth your while taking your time on this, because of course very little of what's going on, in fact none of what's going on now, will ever get to the examiner. But your answer on the GDC is 7.3437, and of course that needs to be rounded off now, as it's the final answer, to 7.34. So you can see it's very important that you give information as you go. It's very important that the examiner can see you understand the situation with this kind of working, and that you make it clear how you intend to calculate the area. Simply putting down an answer on its own will not get you all the marks. Now of course this is only one way of looking at it. We could have turned the equations around and we could have plotted the x values. That could be done in another example.